Now let's take a look at one of RethinkDB's greatest strengths, and that is scaling out horizontally and how easy it is. So notice here that I have one server, one of one connected, and I've got 3 tables in there. And I can look down the list and it says one shard, one replica. That's all very important when you're working with a distributed database system. And here's all kind of information about that table, the catalog table, including where the data is distributed across the shards. And since we have only one, we have one shard, one replica. Everything is pretty straightforward and simple. But nothing ever stays that way, does it? All right, well, let's head over to our console, because what I want to do now is I want to scale out. I want to add another service, and I can do this on the same machine by simply offsetting the ports, and I'll show you how to do that right now. But first, what I want to do is I want to make a directory where the new database is going to keep its data in, so I'll call it R2. Next, I'll tell RethinkDB to launch, and I'm going to set the name of this server to Liam, and I'm going to tell it that I want it to offset its default ports by 1. So I'll show you what that means in just a second. And then I'm telling it that I want it to join localhost 29015. 29015 is the port that you need to connect on for intra-cluster connections, and that is displayed to you right at the startup of your service. So this is Zane's startup, and he's on 29015, and the client driver is 28015, and then admin interface is 8080. Since I told it to do a port offset, all those ports are going to be off by 1. In addition, here with join, I've told it not to start up on its own. Start up and join localhost 29015. Finally, I've tagged this as US East using the -t flag. All right, we're ready to go. Let's, start it up. It looks like I made a goofy error. If you don't specify where the data directory is, then RethinkDB won't start. That's important to understand. It won't overwrite another database's data. So to specify the data directory, I just use -d. And we are up. Liam is running. Hooray! And it's running on the ports that I expect. In addition, it's connected to server Zane. That's exciting. So if we flip over to the web interface, it's already updated itself. Look at that. 2 out of 2 servers are connected. I love how this admin interface updates itself. You don't need to come in here and refresh things all the time. I think that's really neat. All right, headed over to the server window, you can see we have Liam here. It has a default tag as well, which it needs, and then it also has a US East tag. That's good. So we're pretending they're in 2 different data centers. All right, well, let's come down here and monkey with stuff. Right here, I can now reset the replicas and the shards from my catalog table. I can just say I want 2 replicas per shard, hit reconfigure, and some writes go off. And just like that, it's done. Easy peasy, right through the web interface. If I come down here to the servers used by this table, you can see that a secondary replica of our data, the entire table, has been replicated over to Liam. This buys us some redundancy. I'll talk about that more in just a second. So let's head over to Liam. He's on localhost 8081, and you can see the log entries for Liam. And if we go over to the tables, you can see that we can actually query every single table. It's because Liam is part of the cluster. Liam's only duties right now are to carry the secondary replica of our catalog table, but you can access the entire cluster dataset from Liam if you want to. And here I am querying the catalog table, but I could query any of the tables if I wanted to. We're going to get into all of this in just a second.